Hi, everyone. I'm Wayne Sutton, Head of Community at Convex. Welcome to Convex's first Dev Day. Thanks for joining. We have some exciting demos to show you today, followed by Q&A at the end, so stay tuned. To kick things off, I would like to invite Jamie Turner, Convex co-founder and CEO, to the stage. Welcome, Jamie.
All right, thanks, Wayne. Thanks everyone for dialing into our first Convex Dev Day here. So there's a lot of ceremony for us, but we're really excited to be doing something like this. It kind of makes sense in this case to really make this an event because Convex Components really are probably the single biggest change to the platform we've made since our initial release of the platform. So it's something we're very excited about. It's been an effort that we've been working on for nearly a year, actually, and we've been working with a lot of members of our community. So one of the things I want to call out right away is just thank all the beta testers for like all the work we put in together on early versions of components. There were a lot of rough edges and all that kind of stuff. And yeah, between our team and a lot of help from our developers in our ecosystem, like it's been a lot of work to get here, but we're pretty excited to ship them now. So you're going to hear a lot more about what they are soon. So if there are some of you on the stream who don't know what Convex is yet, Convex is a sync platform. It's kind of a new way to develop and manage backend state. It replaces databases and cloud functions, caches and queues, and all these kind of DevOpsy things you normally do on backends with an API. And you embed this library in your app, and you've got this nice product-centric way to model all your backend state in TypeScript. So why would you use it? Well, it lets you build and ship faster, and you have a lot more fun doing it, right? So DX basically, right? So building full stack products and just getting them out the door quickly and having fewer problems and having a lot more fun. So Convex, we released our 1.0 last July. And kind of the story here is that in the last year or so, we've had a lot more developers using the platform. And I think something last check was like maybe 30 times as many people are building products on Convex right now as they were a year ago, projects on Convex. And during that time, one of the things that happens is we've learned a lot about how to solve problems on Convex. And we've kind of learned those things together with our developers, right? So because we released this platform, and then we spent a lot of time kind of side by side with a lot of people in our developer community, learning how they're modeling problems in Convex, how they're solving different kinds of backend architectural tasks and things like that. And so we've kind of been compiling a lot of best practices, and we've been documenting a lot of those in our developer blog and lots of other places, a lot on Discord and things like that. But as more and more of these things were popping up, it just became very clear we sort of needed something like components for the platform to realize its full potential, because there are so many different things you could do with Convex that you want to make sure you've got a good way to scale that, right? All the discovery and the sharing of solutioning to lots of different problems. So that was kind of the background of the components project. And now I'm going to hand off to my co-founder Sujay to dive a lot more into the specifics of Convex and the specifics of components and why this was the right thing to dive into to sort of take this on.
Hey everyone, I'm Sujay. I'm one of the co-founders and I'm the chief scientist at Convex, and I'm super excited to be here with you all, and thanks to all for tuning in, and we'll talk about components for a bit. So first, before we get started, it's very natural to ask, what are components? And we will show you through an example. So we have 4 awesome demos of components that we built that we'll get into soon. But before we do that, we can talk a little bit more in generality about what components are and why we built them. So to take a step back, if we imagine that we're building an app that needs backend infrastructure, there are so many amazing pieces of backend infrastructure that exist out there in the world already. Say, for example, you need a rate limiter in your app. Google, for example, has an incredible rate limiter that they use internally that solves all of their problems. But we expect it to be easy to reuse code. If Google publishes some open source, it's really easy to bring that into our own applications. But for some reason, we don't think it's so easy to reuse backend infrastructure that other developers make. And with components, we're trying to change that for Convex. The goal for components are to make is to make backend infrastructure really safe and easy to reuse. And with that question of why is it so hard to reuse backend infrastructure, pulling that thread leads to the design that we came up with components. Components have code, but they also have data. They have the ability to package up tables that are fully private to the components implementation. Backend infrastructure also has APIs. It presents an API to people who want to use it. So say, for example, with the rate limiter, you need to be able to query that rate limiter to see if there's enough space, and if there isn't, throw an appropriate error. So we'll get into the details of components R through example, and I will turn it over to Lee, who's going to show off our first component for aggregates.
Hi, I'm Lee. I'm a software engineer at Convex, and I built the Aggregate component available now for use in your Convex backend. Let's take a look starting at the Convex Dev/Components, which is a new web page for listing all of the components that are available right now. And let's take a look, dive into the Aggregate. This is the components page, and it's open source. So let's just look at the GitHub repo. We've got a README here, which tells you how to install it and how to use it. So down here, we have installation instructions. You install it from npm, like any other npm library, and you install it in this new file, convex.config.ts, with code like this. And then you use it within your Convex mutations and queries. And let me show you quickly the code to do that. We've got my project, my demo project here. I've got a convex.config.ts. I'm using the aggregate component that I've installed up here. And in here, when I'm using it in my Convex project, I define a class. This is like our interface that encapsulates the component. And then you can call methods on it. Like you can say get, where is it? Like you can get the number of songs. And let me just jump right into the demo. Because this is a running app. So I've got 1 million songs that are in this demo. I just downloaded from some database, and they're sorted by artist familiarity. So each song here has a familiarity score, like 1 through 1 million. And so just a disclaimer, this demo is not going to look impressive. But that's sort of hiding some important details because this is a feature. These are features that many apps take for granted, but they really don't implement them efficiently at scale. And Convex does with this aggregate component. So, for example, we've got this count of the number of songs. In most apps, this would be a select count star, some MySQL or PostgreSQL command. And the way that works is it actually counts all of the rows in the database. So that's linear. This in most databases would be reading 1 million rows. But with the aggregate component, it pre-computes some values and then it accumulates them so that it doesn't have to read. It has to read maybe like 5 documents instead of 1 million. So and I can, but it also has all the benefits of Convex. So we have the transactionality and reactivity that you expect from Convex. We've got a Convex dashboard here. And I can insert a new song. I can say that I created a new song and it's very familiar and it has a name like Hello. And I can run this mutation, which will insert it at the beginning. And that also updated this number of songs. And it updated the number of pages that we have in this table. So I can click through. This is another feature that's not very easy to build with Convex, but is very easy with the aggregate component. You can click through and get each song efficiently. Each page efficiently. So still ordered by familiarity. We can look at the 12th page. We can look at the 12,000th page, and they all load really quickly because they're all doing log n, logarithmic time operations. And yeah, so I can add. I can also remove, and all of this just works. We're just updating the data model, and everything updates reactively. Yeah, see, we're back to the same count as before and the same number of pages. So what else can you do? Well, Convex has text search built in. So if we look for a song, say we look, I think page 21 has a few familiar songs. These are all very low numbers because they're familiar songs. And if we search for them, we can do full text search There's a just built-in full text search, but each one has a familiarity score attached to it, and this is calculated by the aggregates component. So if you imagine you've got a user and the user is logged in and they have a score, then you might want to show this score where they are on the leaderboard relative to all of the other users. And maybe they're like number 10 million in their leaderboard, but we can calculate that really quickly with the aggregate component, and it's reactive and it's transactional. Everything you expect from Convex. Cool. So, and the final feature that I have to show you is we can search, we can go through pages, but since you can look up anything at a random index with the aggregate component, you can also shuffle. So I can get a completely random ordering, and I can paginate through this random ordering of all the songs. I can go to like the last page of the songs and see it just calculated. And these are the familiarity scores just like before. And all of this super fast and ready to use now. And that's it for the aggregate component. So I'm going to hand off to Sarah for the Expo notifications component.
Cool. Hi, I'm Sarah. I'm a software engineer at Convex as well. And I'm going to talk about a component I built that leverages Expo and helps you send push notifications. So Expo is a platform for building mobile apps using React Native. And they have this really good like push notification API where you can basically register your app to deliver push notifications, and it'll handle it with like iOS and Android. And you just get this token that lets you send notifications to that device. And what the Convex component does is it keeps track of all of those tokens, handles hitting the Expo API for you, and does nice things like batching and retries on failure. So I will just demo this. So here on the right, you can see just my phone, my like physical iPhone, and I'm showing all of the notifications that I'm getting from this app where I've set up my own notifications. And then on the left here, this is just like a simulator, but you can imagine that it's just a second phone that I have. And normally you'd have like a real login where you can, sign in with Google or whatever, but you can for now just type in a name, and I can click one of these fruits and send my phone a notification, and it pops up and yay, it works, and that's cool. And we're going to do it again just for funsies. So this is running through Convex and hitting that Expo API. And I also have a cron sending me an orange every minute for fun. But let's look at a little bit of the code here. So that button that I click here when I like type in my name and set up my notifications is calling this function here, which goes through a bunch of Expo setup that they have in their docs to get one of those tokens that lets you send notifications. And then we call a convex mutation to record that. And we're doing some stuff to like create a user, but the important part here is we're calling into the component to record that token and associate it with that particular user. And a lot of this component setup looks similar to what Lee showed before and what other people will show after me. And then when I click on one of these fruit buttons, I'm really just calling a convex mutation, send push notification, and it contains the emoji in the name. And what this is doing is it's just calling a function on the component. And it's as simple as that. You just call send push notification. You can put in things like the title and the user you want to send it to, and the component handles the rest. If you send 20 notifications at a time, and you suddenly have a large volume of notifications, it'll batch them. If Expo's down for a little bit, the component will try and retry them for you. So the idea is hopefully you can just deliver notifications however you want, and this will just work. And similar to what Lee showed you, all the documentation for how to set this up is on our docs page and is also in GitHub. So if you are building mobile apps and want to send people notifications like fruits, check this out. And now I will hand you off to Sujay, who will show you how to search for things.
All right. Hi, everyone. Sujay here again, and I have yet another fruit-themed example component for you all. This time it is geospatial search. So the first kind of question is, what is geospatial search? So let's say that we're building an app like Google Maps, and we want to, say, search for all the types of restaurants in wherever the user is. So the world has, I think, like last I checked, like something like 20 million restaurants. So finding the set of restaurants that are within the square, like right now I'm in Manhattan, is actually like you can't just scan over all 20 million restaurants in the world and to be able to deliver the result quickly to the user. So we need some form of index that helps us efficiently find which restaurants are around our user's current location. In addition to indexing based on the location, if we look at Google Maps has all these ways to filter the results. Like I can say that I'm in the mood for something that's $1 or $2 signs. Of course, I only want something that's 4.5 stars or more. And maybe I want something, I want Indian food. So I have a few results here that simultaneously are near my current location, but then also satisfy these filters. So you may want to have this type of functionality for building something like Google Maps or Yelp, or even something like Uber, where Uber needs to find all of the drivers that are near the customer's current location. So, unsurprisingly, we have built Convex geospatial search as a component within Convex. So here's a little demo app that I have that shows how it works. We have currently the viewport centered around Manhattan, and to keep with the fruit theme, if I right-click on this map, it adds points to the map, just assigns a random emoji. And then I can filter for a given point. So say if I only want to see the tomatoes, I can filter that. But then also I can do something like an inquiry where I allow some set of different fruits. So I think like maybe I want a cherry, and then I think I also saw a mushroom. See if I can find that. And then those are the two ones I've seen so far. Oh, and that over there. So the other cool thing with this component is that in addition to working for search, like the kind of other demos we've had, since it's built on Convex, everything is fully consistent, cached, and reactive. So I have two viewports here. And if I click a bunch of fruit on the map here, you can see that it is updating in real time on the view on the right. It's taking a little longer than I thought on a touchpad. That's a high. Cool. So this type of index is really useful if your app has any need to track things that are on Earth's sphere. And one of the things that's really cool, and this is the blue rectangles that are showing here in our debug view, is that Google has open sourced the library that they use for implementing Google Maps internally, and it's called S2. And one of the cool things now with this geospatial component is that we are leveraging S2 internally to really efficiently search for whatever points overlap with a given rectangle on the sphere. So we've tested this with 1 million points, and we'd be, curious how it works for y'all. Okay, so like everyone else was saying, all of these components are open source and they're up on GitHub. So I have the geospatial component here on GitHub. It has the instructions for how to use it. Importantly, installation is super, super easy. All you have to do is just npm install this component and then link it into your app with these blocks of code. And then it's really easy to both insert and query points from that index. So let's take a quick look at what that looks like. So in the example app, which I was just showing, we create the geospatial index with this constructor here. And adding a point is just as simple as doing geospatial.insert with a unique key for the string, the point, and any attributes you may want to filter on. In my example app, all I needed was to be able to filter by the emoji itself, but it'd be really easy to put a price field on here or a cuisine or whatever other things you may want to filter on. Then when it's time to search, it's just geospatial.query. You can specify the shape that you want to query. And then optionally, if you want to filter that even more, you can use this filter syntax, which should be pretty familiar if you've used our vector search. So that's pretty much it. It just works. It's really easy to install. And what normally might have needed setting up a completely new database and backfilling data into it is just a component that you can use right next to your regular data. So with that, we will go to our final component demo with Ian.
Hello. And I have more fruit to share with you, I will say. So I want to show off the LaunchDarkly component that Ari here worked on in collaboration with LaunchDarkly, who's a launch partner today. And so if you don't know what LaunchDarkly is, they do feature flagging. And if you don't know what feature flagging is, you can imagine, it's useful to have to be able to customize the behavior of your app without having to redeploy your app. So you might think of these as like environment variables in Convex. When you update those, your backend behavior changes. And with feature flags, you can both have these flags change front-end behavior and change back-end behavior that you can modify from like a web UI. That's really nice. And the cool thing about this component is that typically when you're using LaunchDarkly and feature flagging services, you will make a third-party request to find out the value of some flag. And while that is all well and good when you're kind of like in an action or in some sort of non-deterministic situation or environment, it doesn't work as well when you're inside of a transaction inside of Convex, inside of a query, or inside of mutation. And so what this component allows you to do is kind of access those values from within Convex itself. So let's see, my cursor's a little laggy here. So here we have a flag for whether I can buy fruit. So over here I have a little fruit store. If I try to buy fruit, it says I can buy it. If I disable this and confirm, then when I go over here to try buy fruit again, wait, let me save. Did I say that correctly? Okay, flag saved. There we go. And I come over here to buy the fruit again, and it says I can't buy the fruit. And so you might imagine that you might be doing this flagging on the front end, but you actually here can be accessing these flags from the back end. So here's the front end code. It's just using a regular query and mutation that you'd expect to see, and just mapping over the fruit and calling the buy fruit function. And on the right here, we have the backend code. And for this mutation, we're accessing LaunchDarkly from within the mutation. We are checking the can buy fruits value, and we're returning that error if they can't. And so that's pretty cool. It means that you can be changing the behavior of your server-side code within Convex using LaunchDarkly's UI. But it also extends to queries. So here I have a query on whether I can show fruits. And when you do these feature flags on the front end, right, you might be deciding whether or not to show one UI or another. But actually having these checks in the back end means that you can prevent users from even querying those fruit. Maybe that was a really, like the fruits are data that's really private, and you only want certain people to be able to access them from the API in the first place. And so that code works the same. And when we kind of go and modify that flag, if I can get my cursor here to work, we can modify this as well. And because this is convex, and as we've said, that means there's reactivity and everything's kind of real time. When I update this value, it will actually update the UI through the query. So this is, every user that would be seeing this could be seeing the values be kind of like live update. So again, when we re-enable it, all of a sudden they pop back in. And you can see this happening in the component dashboard. So within the dashboard, you have a page for your app But here I have my LaunchDarkly component, and one of the tables in there is the data that we get back from LaunchDarkly. And so when I update this rule, you can see over here, or I'll scroll over a little bit. Sorry, give me 1 second. Okay, you see that the version is 24, and that should update. So the cool thing, and I'm not sure why okay, there we go, 25. So the LaunchDarkly is syncing to the components data, which is then syncing to your app. And so looking back at the code, all it took was just accessing that value through the LaunchDarkly API. And to show you a bit about how this is configured, similar to other components, you install the npm library, convex dev/launchdarkly. You add it to your convex.config, which is a file that we've added for components in order to kind of configure all the components that you might want to use, and this will have kind of more functionality in the future. And then when you go to use them, it's just as easy as we saw. That also here is like registering some HTTP webhooks that LaunchDarkly calls into for the component. And on LaunchDarkly's side, there's now a first-party integration with Convex where you can point the your LaunchDarkly instance at your Convex backend. So here I have successful Greyhound 504. I paste in a token that the component on Convex side creates, and that that's all it takes. It then sends it to the webhooks that go into the component that save the data, and it gives you the full UI and the full API to be able to do all the fancy things you can do with LaunchDarkly. They're kind of like, this is their bread and butter. So you can have segments of users, you can return more interesting values than true and false. You can have like a whole series of logic and kind of capture which users are in which segments and then track their behavior. And you also get interesting information about like evaluations. So any times that you are evaluating rules within a mutation, it will actually log that back so you can see, which users saw which variants. So hope this is really useful. Excited to hear what people think of it. And with that, I'll pass the mic back to Wayne.
Thanks, Ian. Thanks, everyone. And next up, we're going to do our Q&A, and I'm going to bring everybody back to the stage and answer any questions you may have. All right. Hello, everyone. I think, Jamie, you have some words?
Oh, I was just going to mention real quick that thanks, everybody, for the demos. And these are 4 of the components and each of these folks that they authored and did an awesome job at. There's actually, I believe the count is 12 components we're launching today. So this is just 4 of 12 of them. So make sure to go check out convex.dev/components just to get a sense of some of the other things. There's a whole bunch of really cool stuff on there. So just wanted to mention that as well as like awesome sample of the stuff. And there's a lot more available there too.
Sounds good. Sounds good. Thanks, Jamie. Yeah, we got some questions from the audience, so I'll feature them on the screen, and then feel free to jump in. Let me see. Up first, about the geospatial component. Sujay, I think it's for you.
Yeah, totally. Yeah, that is a good observation that if you go to the GitHub and you see the languages that are used, it is some JavaScript, TypeScript, but then just a little bit of Go. And yes, that is something that you can do with your own components. You can even do it in your own regular convex functions. We haven't really gotten the DX in a good place yet for authoring WASM component or WASM binaries and using them within your convex functions. The like geospatial one is just us like dipping our toes a little bit into there, and the DX wasn't that great for me to author it, but we'll be working on making that better in the future. And it's just really cool to be able to use high quality libraries like the S2 library from Google is really, really good, and use that to power our platform and make it a lot better.
Awesome. Thanks, Sujay. I think this is a question for I think Jamie and the team, is about the future of components.
Yeah. Yes, that's correct. That is the vision for sure. So we would love for there to be a relatively large, well, I say relatively, a large marketplace of components eventually. You know, one of the things that's been kind of fun about the beta period is that the early users we share components with, one of the first things they asked was, "Can I write some of these?" And our answer there is like, yes, actually, in the future, we would love to have most of the components being created to be created by teams that are solving specialized needs and stuff like that. And then this convex.dev/components to us is the start of kind of the components directory, where we're quite happy to list other people's awesome components they made there as well. Including if they're building a component to couple Convex to their service, if they have a SaaS business or whatever, that works as well. So we haven't yet figured out the process by which we're going to manage like submissions and listing in that directory, but it's something we'll figure out and keep doubling back with the community as we have updates there. So definitely, it's going to be a marketplace of apps. The Convex authored ones we're kind of working on bootstrapping the ecosystem with a lot of the most pressing things we know people need. But yes, over time, we're imagining most of the things in there will be written by other teams, and that would be great.
Awesome. Let me see. Up next, we have another question from Eva. How do you imagine supporting and maintaining these components over time?
Yeah, I can take this one. Yeah, so I think it's very similar to how we would think of just like if you have a third-party service and you have an SDK that is talking to that service, like components are kind of like supercharged SDKs, and that they have code, they talk to external services, but then they also store data and potentially have background jobs and things like that. So I think like the plan would be just to version it in the same way that you might version code on NPM or any other package manager. So then, you know, if you wanted to, if they're, say, Stripe released a new version of their API, then we would have a version of the component that then would support that, and we would release it, but old things would continue to work. And then developers who use that component could upgrade to the new version over time. So in terms of ownership, I would, similarly think of it like SDKs, and that for components that we author, we will keep up with changes in those third-party services and publish new versions. But then if someone else is maintaining a component, then they would be responsible for maintaining that over time as well.
Thanks, Sujay. Let's see what else we have. Wait, does everyone hear us okay? Just checking the audio. Up next, if I want to build a private component, or the guidelines for doing so. I believe we touched on this, but anyone want to jump on that?
Sure. Yeah. The truth, right now there aren't, but we will publish some soon. We're actually we wanted to get the initial components out the door, and really we've gotten a lot of feedback on the using side of components. The authoring side of components is we're still refining, and so we'd love to polish it a little bit more before we publish documentation on making your own. But that is a huge goal of ours, and something we're being driving at really quickly so that we can get there as soon as possible.
One other thing I'll add there is in terms of for private components, another part of our vision here for components is that it makes it really easy to use other people's backend functionality. So if you need to stitch in the geospatial index or the Expo notifications, that's something you can do with components. But then as developers start having larger and larger apps on Convex, then these types of private components where you take your own app and then break it up into pieces that are isolated for each other is part of our vision of how developers can have larger and larger apps on Convex. So private components are definitely a big part of what we're thinking for that.
Awesome. Thanks, Sujay. Another question would jump in about Flutter.
Honestly, the answer to a lot of these things is maybe. We have a small team, and there's always a lot of new surfaces we want to take on. So Flutter is something that actually most of the interesting stuff that's happened so far has been community development, where someone in our ecosystem that is like, okay, I've been waiting on this, you guys. This is exciting to me. Goes out and makes one before we do. So I think Flutter is definitely one of those platforms where what we'll probably do at some point is take a look at what the ecosystem has made and either contribute to it or adopt it or talk through with them about the approach they took. We do now have a developer on staff who's been working on a lot of mobile work recently that has a lot of experience with Flutter, and I actually think he is interested to figure it out soon. But we don't exactly know the timeline yet. We kind of got to get through components and a few other things before we take on Flutter. So sorry, it's a little bit of a vague answer, but we probably won't have a first party Flutter support in the next month or two. We might visit it after that. But in the meantime, if you're not in the Discord, our community Discord, join the Discord, because there are some cool Flutter bindings that community members have made that we're happy to point you to.
Awesome. Thanks, Jamie. Up next, a question for someone watching on LinkedIn regarding billing. We'll be able to see separately see the usage done by a component in the future.
Yes, absolutely. So we, even out of the gate, we built in very early, because we know how important it is, that tracking usage and resource utilization to components, it's all tagged already. So we'll be rolling out the visibility of that over some time. But yes, we want to make it very clear when you import a component how much of your bill is the component's usage, so that there's good accountability there and stuff like that. So there's also a version of the vision of that where we're exploring, it's pretty early, doing some kind of revenue share thing with component authors down the road, so that if you build something that's a really valuable component that lots of people are using on Convex, and so therefore you're adding value to the Convex ecosystem, we find some way to share that value back with you, either as a company or as just an open source developer. So we don't have a timeline on that yet, but it's something maybe in the next 12 months or so we'd like to figure out how to start rolling out. So for all of those reasons, both the clarity of you understanding your bill and this ability to give back to the ecosystem, tracking resources by component is definitely part of the vision.
Awesome. Thanks, Jamie.
And actually, I would like to just build on that for a second. There's because there's a whole bunch of things that you want kind of segmented per component, right? There's billing, but there's also your logs, right? So on the dashboard, you can filter by the logs that are coming from a component versus the logs that are coming from your app. Also the log streams that go out to your monitoring service or whatever you're doing for stats. You'll have be able to isolate the logs that are and the activity and the usage that is coming from components versus otherwise. And there's also, as you saw on the dashboard, the data is segmented, and the dashboard can kind of show that in its own kind of little world, as well as file storage, as well as the scheduler, right? So all of the things, all the kind of building blocks that are in your normal app are also kind of have their own little namespace within your component.
Awesome. Thanks, Ian. Next, another question from LinkedIn.
Yeah, I can take this one. So the question is, how do transactional guarantees across components work, especially in cases involving multiple database rights? So this is a really, really interesting question. And before we kind of get into the details of what we built and kind of where we landed in the problem space, we'll just go back to one of the design goals for components is that we want to make it extremely easy and to compose components so that if I'm using a workflow component and then that's using like the action cache component, that everything can just fit together, and that if those components work when they're developed in isolation, they continue to work when they're composed together. And so in service of that, where we landed was something very similar to what are often like called sub-transactions. And this is, is really influenced by a paper called Argus from the late 80s. It's actually from James's PhD advisor, or one of our co-founders. And the core idea is that when a component, say component A, calls into component B, then it starts a new sub-transaction for B's writes. So B can execute, it can do some of its reads, it can do some writes. And then if B throws an error, all of B's writes are rolled back, but then A can decide to continue execution. So that way, we never leave B in a broken state, where because of A's decision to catch the error, B is put into a bad state, which means now it will no longer work. Similarly, if everything goes well, then if A calls B, B calls C, and it goes all over the place, at the very end, the top level transaction will commit, and that will happen fully atomically, and it will happen with full consistency like everything else in Convex. So then what that means is that whenever I'm writing the implementation of component B, I can just reason about B in isolation, and then know that the internal invariance about my state and my private tables will always continue to hold. So that's consistency. But then as an application developer, when I am calling all of these components together, then I also know that all of the writes will happen as one big transaction, and I won't ever have some partial state that gets written to some components and not others. So there's some pretty interesting implementation details here around how we coordinate the transaction with, for example, running different components in different V8 contexts to have full isolation between them and to have very low overhead from calling from one to the other. But we can write a little bit more about this, and as we and continue to optimize our system and talk about things like that.
And one thing I just want to add to that real quick is that obviously Sujay's description of this is excellent because he understands it in great depth. But and the goaling that sort of drove that, right, is that in Convex we want things to just work, right? And so at a high level, the transactional guarantees across components are as strong as the ones within the individual mutation in your app. So if you want to catch sub things and be able to reason through partial rollbacks or whatever, that you can do that. But if you just write it in a straightforward way, it's probably going to do what you expect. And the introduction of components does not complicate the consistency model in any way.
Nice. Thanks, Jamie and Sujay. Next, we have a question on workflow indicator.
Sure. Yeah, I can take this. Any plan to track the progress of a workflow with something like progress indicator? So this is a question about our workflow component, which is one of our 12 components, but then we didn't demo today. It provides durable execution on Convex. So if you want to have a very long-lived process, say when a user signs up, you might have a state machine that decides after a week whether to send them an onboarding email, and then based on maybe after a month after their credit card bills fails, do something else. Durable execution lets you specify those state machines in just plain code. So in the middle of your code, you can do something like time.sleep 30 days, and it just works. So the question then is, for the workflow component that we built, is there any way to track the progress of where that state machine is? Is it currently waiting on a 30-day timer to see if the user is going to update their credit card information or something like that? The answer is we don't have that today. The kind of workflow component is really bare bones, in that it has just the core of durable execution and not all of the kind of supporting features to make it really ergonomic. But we've filed a lot of these in GitHub issues, and those things we'll be knocking out. So it's good to hear that there's interest in this and that this is also a feature that's important. For now, if you would want to be able to report progress from within a workflow, workflows can always just call queries, mutations, and actions, just like regular Convex actions can. So at every single like kind of state transition or at different important points in your workflow, you can call a mutation that would then go right to some table that you manage that would then signal that, oh, this like user is in this state or it's at this point in progress. So for now, it's just kind of progress reporting is at the application layer, and then eventually we'll have some APIs to be able to look at the internal workflow state and see where it's currently.
I think that the workflow component probably represents the one where like most of the components we're releasing today they represent 70 or 80% of the vision. The workflow component is one that probably represents 8% of the vision or 12. There's a lot to do there because it's a really big space. But it's a related thing we haven't talked about yet to this question that you've asked here is that we have a vision of the components framework that we haven't implemented yet, but is going to be amazing when we get it, we hope, which is the ability for components to have an in-dashboard UI as well that they can eventually register. So that, yes, sure, they could give APIs so that you could attach your own, tracking to it, whether it was telemetry like Datadog or something like that, or whether it was your own UI. But like we also too would love for components if there's a visualization they think should be in the Convex dashboard for their state, including one that calls mutations, maybe to manage that state. We would like to have that be a part of the components framework eventually. That's not there yet. That's probably some time away. But yes, workflow is a great example of a place where like you would love to be able to have some kind of representation, tells you what's going on in there and how is progress being made.
Awesome. Thanks. Up next is a question around the triggers and aggregates.
Yeah, I can attempt to take this one. So the question is, I was going to use a trigger to keep track of a count. Just read about that yesterday. Seems like aggregates take care of that. So aggregates, at least the way I demoed it, uses triggers. So this wouldn't be that much different from using the trigger yourself. There's also, in addition to the aggregate that I showed today, there's also a sharded counter component, which is even better than the aggregate component for the specific use case of keeping track of a count. And that one also integrates with triggers. So they are built to work with triggers. It's like a one line or a few lines set up to set it up with triggers. But that is how they work today. I could move to ask Jamie or Sujay to talk about the future of triggers, but that's what the state today.
Yeah, I can talk a little bit about that. So even like for a lot of the components we have, so like with Lee's aggregate component, also the geospatial component I demoed, the way that we're currently thinking of these components is as like adding new data structures to Convex, so that when you have your tables that are inside your app, I might have like a restaurants table in my Yelp clone app. Then I will maintain the restaurants table myself, but then on the side, I'll maintain this index that then contains just the points and then efficiently lets me figure out which restaurants I want to show to the user. So there's this model where there's like your kind of table that you manage that has all of your data. And then whenever you make a modification to that table, you're responsible for also doing the write into the like separate data structure, whether that's the aggregates or the geospatial index. And one tool for keeping these two in sync more easily is then using something like triggers, where if you use that custom mutation that comes from the trigger, it's very easy to connect the write for your own data with the write to the separate data structure. In the future, one set of APIs that we're currently thinking through and ideating around is to make it so that this can just happen automatically, that it's easier to keep tables in sync, where you can just have your like restaurants table, and then you can pass some handle to that table to the geospatial component and have it automatically stream updates from the restaurants table to your component. So that is, work in progress. That's going to take some time, but it's kind of similar in spirit to what we have for streaming export, where it's easy to take your Convex tables and stream them through like Airbyte or Fivetran. You could imagine it being similar to happen internally within your app, but there's that's kind of a work in progress.
Awesome. Thanks, Sujay. I believe that's it. Did we touch on this around workflow components? I think we did. Yeah, awesome. Great. Well, I think that's it for questions. And just want to say thanks everyone for joining for our first Convex Dev Day. And thanks to team for participating and for answering all the questions, for the demos, and hopefully to see everyone in our Discord community and using Convex. So thanks everyone, and see you all online.